How's it going, everybody? This is Filament Bros. Today we'll be going over how to install and operate the Bambu Lab slicer Bambu Studio. Our first step is to go into our web browser and look up bambulab.com. This will take us to the Bambu Lab page where we can navigate towards software and Bambu Studio. From here, we have multiple options as to what to download. We have Windows, Mac, and Linux. This Linux version gives you a GitHub page, which will give you the directions to install it there. My computer is a Windows, so we will be installing the Windows edition in this tutorial. We'll go here, download it, and then we'll go ahead and open that up soon. Once that is installed, it will give us the Bambu Studio setup wizard, which we later go through and click through these. Choose our destination folder and hit install. Now that the installation is complete, we will click next and then check mark all of these and close, which will open and run Bambu Studio. Now that Bambu Studio is open, we can take a look at this home page. Here you can access recently opened files, online models you can download and print, files from the Maker Lab, and your print history. Now if we go up to the top, we can click Create New Project, which will take us to this page. This is the Preparations tab for Bambu Studio. At our top left, we can see our printer types. We recommend purchasing the A1 printer, but put whatever printer you have in this selection menu. The A1 comes stock with a textured PEI plate, and you can select that plate type here. And you can also select your diameter of the nozzle in this spot. The A1 comes stock with a 0.4mm nozzle. If you have an AMS automatic material system, you can also choose which filament types correspond to your AMS system in this area here, as well as color code it. Now to add an STL file, you can click this button right here to add, and then you'll double click on your STL file and it will import it into Bambu Studio. Another way is to go to your file and drag and drop it in Bambu Studio. The third and final way to upload is to double click on your STL file and open with Bambu Studio. However, this opens up a new window completely separate. Let's look at some of the settings we have. So our next setting is add plate, which sounds pretty self-explanatory. You just add a plate in there, and it helps if you have larger prints or other things going on. You can plan out and have complete control of that. You also have the arrange all objects, which will move your objects to a certain location, allowing it to be in the most optimal position to print. Another tip here is this panel down at the bottom right. This is the repair tab. So you can see if you import using SketchUp or Rhino, AutoCAD, all of these things. Sometimes there are little mistakes there that your STL file doesn't read. And in order to repair that, you can go and click this. And this is a great first line of defense just to ensure that you reduce the possibility of print failure. So now all of those lines have been smoothed out and our print is pretty much ready to go. Some other settings we have are the split to objects panel, which this object is a solid. However, if I were to import a file that is not, such as these window frames, we can go ahead and use that add plate and split this to objects. Now this will make each of these window frames its own separate piece instead of being a whole part together, which is extremely useful when importing a large quantity of parts. You don't have to have multiple STL files for each of these. You can just import it, split to objects, and you're good to go. Split to parts is very similar, except it is specifically for meshes. So it is not as relevant as this when using architectural models. The next feature is going to be the variable layer height. And this you can right click along here and increase the layer height, like so. And it will color it green to increase the layer height. And then if you go ahead and right click, it will turn red. So left click to green, which increases, and right click to red, which will decrease the layer height. And you can see throughout here how that gives you more control of your planning. I'm going to reset that, get out of there. You also have the Move tab, which allows you to move objects on the 3 axes. So this is pretty useful, but you can also just click it and drag it like so. You have the Rotate, which once again, you also have the axes available and you're able to rotate as well as lock onto these lines here, giving you exact measurements. The next feature is going to be the Scale feature. You can scale it uniformly by the corners. You can also stretch and compress by using either the blue, red, or green axes there. So I'm going to go out of that. Another very important feature is going to be Lay on Face. So Auto Orient does a decent job of this, especially when having multiple parts like that. And then we can also auto arrange and see how that lays nicely. But let's say you have another print that you would like it to rest on another face. You have complete control of that. So sometimes Auto Orient will put it on a side like this, and you need to go ahead and boop, move it back, and you're all good to go. So Auto Orient does a decent job, but Lay on Face gives you complete control of that. We also have Cut, which is very useful when using larger scale models like this. So I can go ahead and create a plane and then figure out where exactly I want to cut, and then perform the cut, which will split it into multiple halves. Let's give you a better view of that. So now it splits it into multiple halves here. Something else to note about Cut is if we go into the Cut menu, we can add connectors, and this will make it so that your model will actually stick together. So we can go and add all sorts of shapes to here and click it in there, which will create plugs and holes, and it will correspond to each half of your shape. So you go ahead like this, you confirm your connectors, you perform your cut, and now you can see there's these plugs sticking out. And if we take a look at this other side here, you should actually be able to see the holes that were created. So this is very useful in making sure that your parts piece together accurately. Going back out of there, we also have this feature, which is Mesh Boolean. This is more if you have assemblies that you're putting together. It's a bit more complex of a tool, so we're not going to get into that today, but we will have more content covering meshes and booleans. We also have support painting, which sounds basically like what it is. You go ahead and you just use your mouse as a brush, and you can paint supports on. So if I want this to be structured and supported, I go ahead and paint that, and boom. When we go ahead and slice, there will be a support going right there. The next is going to be seam painting and printing. You will have a seam, which is a line in your print somewhere, where the filament head will go and move up and continue extruding along, which creates these lines. So if you want that seam in a specific place, you can go ahead and click this and draw your seam, which will indicate where exactly you want the print head to move up. You can also add text, which is through this one, and then you just put your text. So let's say hello, and that will allow you to add it wherever you choose. You can change font, size, thickness, all of that. Some of our other features are color painting. So if you have the automatic material system, you can go ahead and paint different colors. So we have this green here. So if I wanted this green and filament type 5 over here was associated with green, then when you slice it, this is going to print as green. We also have the measure tool. So we can take multiple sides and it generates angles as well as distances. Let's see if we can get a distance in here going. There we go. So now this helps you to accurately assess the quality and dimensions of your project. Very useful tool. We also have the assembly tool, which if we have multiple parts, we can go ahead and, this is still a measure, excuse me, the assembly. So this will tell you dimensions and the different meshes behind them. However, if we go ahead and take two of these pieces, we can assemble them together. So I could say this face and this face need to connect, and then center them, and now they're connected. So this is very useful when doing assemblies and just assembling different pieces together. And finally, we have the brim ears. So oftentimes when you have a large base like this, you will have a brim, a filament going around, which reduces the chance of warping on the edges and helps with adhesion. So you can go ahead and place these brim ears, which will help you to pull the print off the plate without having to bend and potentially damage your build plate. So you can also adjust the size and dimensions of these just to make it a little bit easier for you to get your print off the plate. And then we can look over here. This is the last one. This is the assembly view. So if you have parts assembled together like we had over here, it would display as the objects are going to be assembled in this view. And you can play around with these and assemble pieces together. Next, we're going to take a look at some of our settings down here. So we have both object settings and global settings. Now, object settings are going to pertain to a specific object within your project. However, the global settings affect everything. If we go down, we have presets. So there are standard presets that are set by Bambu, as well as user presets. And we will be coming out with some Filament Bros presets, so you can use the exact presets that we use on our prints. However, typically the system just puts you to one of these presets, the standard 0.2 millimeter. And then I'll go ahead and give you some recommendations from there. So we have quality. Quality, I wouldn't recommend touching. This does a pretty good job. And now we go to strength. Now, strength, I would recommend turning your sparse infill pattern from grid to gyroid, which reduces those cross sections that can induce warping in your prints. And I would turn this down from 15 to a bigger print like this. You can do 4 or 6. However, if you have a more detailed project, 10 to 12 is typically more than enough. And then that should be good for here. Now we go to speed. Now speed, I primarily don't touch except for the top surfaces. When we reduce the strength and cut down on cost and materials that way, we want to make this top surface much slower, which will reduce the chance of warping and sort of scratchy surfaces on the top. So bring that down to either 900, 950, or 1000 millimeters per second squared, and that will give you a nice smooth top surface that you don't have to worry about. Our next section is support. So I always enable support on mine. I highly recommend using tree supports, and style, go for default or tree slim. Slim is going to reduce the filament cost, but you can use any of these. So for models like this, you may have trouble getting filament out and the supports out, and you may end up breaking windows, especially when doing architectural projects. So something I recommend doing is supporting critical regions only, which reduces the supports from going inside these spaces, making it difficult for you to get out. However, the bottom surfaces may get a little bit stringy, so that is just something to keep in mind and weigh your options there if that's something you're looking for. Another feature is in others, and that's going to be that brim. So, when we painted those brim ears, we're going to actually add a brim, and this is going to be outer brim only. And I would set this to about 5 millimeters there, and just that will have it so that when it slices, there's this nice brim around it, just making sure that there's nice adhesion to the plate. And from there, we can go ahead and slice the plates with those settings changed. So this is going to go layer by layer and see where exactly supports need to go, create the G code, which is the path in which the print head needs to travel, and then give us an estimate on cost and time. So let's go ahead and slice this plate up. Now that our project has finished slicing, we can go ahead and take a peek at what's going on here. So we can see just all of this tree supports highlighted in green that are supporting, as well as that brim around, which is going to be the blue feature there. And something I always like to check is to go over here and start cutting away and just making that there's no errors in there. So I'm seeing some of these would be a little difficult to get out, so I would probably go back and turn off to where tree supports are only in critical regions. But you can go ahead and just check through this, make sure that everything looks good to your liking. You can go ahead and see that gyroid infill that we requested earlier. Check this out, just make sure everything looks good. Always something fantastic to check before you print or before you send over a file to us. And then we can also see the estimated cost as well as the printing time. So this would be around $14 and take 1 day, 1 hour and 5 minutes for the model, and then 1 day, 1 hour and 38 minutes. Another feature that is fantastic when estimating cost is if we go over here to our filament types, we can go and edit this and we can change our cost per gram or per kilogram. So let's say you bought filament for $15 a kilogram. We can go ahead and do that. It'll go ahead and reslice and redo this, and then it will give us a new estimation based on your price. Now, these slices are just estimations, so there could be a slight fluctuation in cost or materials use, just depending the environmental factors of your printer space. So let's go ahead and let that slice again, and then we'll take a peek at how that changed it. So now we can see that the cost went down a little bit to $10.48. And that's just a nice way to just take a little look at what your materials cost will be. Now from here, we can see our total cost per all of the plates and go over and select our plate. And now to print our plate, we will go and make sure your printer is turned on. And then select print plate. It will bring this pop-up menu here, and you go ahead and select your printer. And from there, let's see, it will sync your information, and then you can go ahead and turn on auto bed leveling and flow dynamics calibration, and then send this off to your printer. So this will prepare your print job, send it through Bambu's cloud service, and allow you to go ahead and print and download. This is the device page. So we are able to take a look at our device. You can see some statistics here from the bed temperature and the nozzle temperature. So you can check this out. You can also see the fan, the speed of the printer, and the lights. So you can turn on and off the light. You can also check out the axes here as well as extrusions. You can see this is downloading here. So this will download all the way, and then it will give you an estimated time on this bottom corner here. And then we can go ahead and also, if we click this, it will go and turn on the camera on your printer. However, we are downloading, so we can't access that feature right now. But this is a great way to check on your print as it's going through, especially if you have the Bambu Handy app, which I highly recommend you get. And that will allow you to keep an eye on your print, make sure nothing's going wrong, and just make sure that everything's all right. That concludes our first tutorial. I hope you enjoyed. If you have any questions or comments, please feel free to leave them down in the comment section below, and we will try and answer as many as we can. If there's anything else you'd like to see in future videos, also feel free to comment, and we will keep chunking out videos. Thank you so much for watching. I appreciate it.